go. If you don't have the booklet, then write it into your exercise book. But there's only one formula to work with. Here we go. This is called area of circles in exercise 4E. This is the formula. I want you to write it down. Area of a circle is pi times radius squared. That's what's in your textbook. But there's one little thing I'm going to add on. Okay, so I'm going to add on this one because it helps you for the next exercise. So pi times r squared times, and I want you to write here, theta divided by 360 degrees. Write that down. Write that down. So pi times radius squared times theta over 360. What is theta? That symbol up here, that theta symbol, represents angle. So it's the angle of the circle area that you're interested in. Now hopefully you've looked at B. If you looked at B, you know what a radius is. Radius is from the center of a circle to any side of a circle. That's called the radius. We use the letter R to call that the radius. What was the name again for from the center of the circle? If it passes through the center and it goes all the way across, what's the name for this again? Hands up. Marshall. Diameter is correct. So we know when it comes to the area, we're using radius, not the diameter. Okay, the diameter, you'd have to half it to get the radius. So diameter is double that length. Diameter is double that radius. All right, so today's rule, very simple. It's pi times your radius squared, not diameter squared, times by theta over 360. You won't find this theta to be useful until you get to problem solving. And when you get to exercise 4F, that theta over 360 will be much more useful. Okay? But in a nutshell, this is what I'm trying to say. This will get you the area. This will tell you which part of the circle you want. So do you want the full circle? If it's a full circle, then it's 360 degrees over 360, so hence it's 1. Okay, but part of a circle, so that's where if you're doing a quarter of a circle or semicircle, that's where the angle comes in. Okay, so I'll do some examples so you understand what I mean. But for now, let's do full circles. On the bottom here, your textbook in exercise 4E will ask you sometimes, they'll say to use approximations. You never use 3.14 just because you're lazy. Okay, if the question doesn't say approximate, don't use 3.14 or 22 over 7. It's only when they say approximate your answers. The way that you should be doing it is on your calculator, you should actually find the symbol pi. You need to find that symbol there. Okay? That is the correct exact value of pi. So if they just said find the area of a circle, you must use that. If they say find approximate area of a circle, then it's okay to do 3.14. But if you do 3.14 for a question that doesn't ask for approximate, you'll be slightly off in terms of your answer. And at year 12 level, so the year 12s just had the methods exam just yesterday, and they have another one today. 1 decimal off. So if you wrote 3.13, you'd lose a mark. Okay, and it has to be exactly correct. So that's why we always make sure there's a difference between approximate and an exact value. Okay, so when you're doing these problems, make sure on your calculator, use the symbol pi and not 3.14, unless they ask you to. All right, here we go. Let's do an example. So in this question here, am I going to use an approximate value for pi, or am I using the actual pi symbol? Read the question. Which one is it? Approximate or the pi symbol? Pi symbol. This one doesn't say find the approximate area. It just says find the area. So here, because it says find the area, then we're going to use the formula for a circle. This is a full circle over here. So we say it's pi, so we keep it as pi on your calculator times. Now I need to know what the radius is. What's the radius of this circle? Can I please have, let's go with Eric. What's the radius of this circle? 4, very good. Radius is from the center of the circle to the side of the circle, so radius is 4. So it's 4 squared times. Now, the angle is meant to be out of 360, which is a full revolution. That's the angle for a full revolution. Do I want a full circle, or do I want only part of a circle? Full circle or part of a circle? Full circle. So we know if it's a full circle, it's a nice 360 degrees. So you write 360 over 360. Man, the logic here is, what's 360 divided by 360? Can I please have a rod? What's 360 over 360? 1. That's why in your textbooks, often exercise 4E, they ignore this part. Okay, they don't tell you that. They just say the area is pi r squared. But then when you go to exercise 4F, or you do the problem-solving questions, you need to understand that logic. This is the portion that you want of a circle. This is the area. This is how much of the area do you want? Do you want half of it? Do you want a third of it? Do you want only 45 degrees of it? How much of it do you want? That's where this comes in. Okay? So, put it together. Let's type on our calculator. If you've got a calculator, type it in. Pi, so find the pi symbol. And my calculator is a senior calculator. I can actually type pi. It just means pi. So, pi times, and it was 4 squared times, and I know it was 360 over 360. So, on the senior calculator, I can actually type the fraction. If you can't type the fraction, you can do it this way as well. Open bracket, 360 divided by 360. It means the same thing. Okay? So if you've got one of those scientific calculators that you can't do a fraction, that's another way of doing it. Okay? So if I press enter, I should get 50.2655. Write that down. So here we go. We get 50.6255. Don't forget the units. What's my units? Centimeter, but because it's area, I'm missing the squared. Now the language when we use area, we don't say centimeter squared. That means something else. This actually is called squared centimeters. So when you go buy a house later on in the future, they don't say meters squared. They actually say squared meters. And there's a difference when you buy a house. They talk about squares. So is it 24 squares or is it 24 squared meters? Later on, you'll understand when I talk about rooms and I draw pictures for you. But a general average room, say your room right now, is probably about 9 squared meters. Okay, so 9 squared meters. And what that means is your room is about 3 meters by 3 meters is the average room. Anyone who has larger than that, so say 4 by 3, so 4 times 3 is 12, that's considered quite a big room. So your parents' room, for example, a master's room could sometimes be 4 by 5, so it's about 20 squared meters. But that's the language. I'm saying squared meters, not meters squared. Okay, so just get used to that when you're dealing with the real world stuff. But there you go. We say squared centimeters there, but the answer is not 50.6255. What's the correct answer? What was that? Someone mumbled it just now. 50.6. The question said add correct answers to 1 decimal place. Again, if this was a year 12 question, you left it like this, 0 marks. Okay, it has to be exactly 1 decimal place. So here we go. Next one is 50.6 squared centimeter because we only want 1 decimal place. So we'll take, after decimal place, we'll take the first digit, check the next one. If it's 5 or more, round it up. But since it's 2, we'll leave it as a 6. And that's how you do the first few questions of exercise 4E. Yeah? Let's do another one. Let's try this one. This question says, use the approximated value of pi, which equals 2217. Do I use the pi symbol on approximate value for this question here? Can I please have the nuke? Part B, do I use the pi symbol or do I use the approximate value? And what's the approximate value here? Very good. Don't use 3.14. So you listen to the question. If it says for 3.14, use 3.14. In this case, we are using 22 on 7. What's my radius? Can I please have, let's go with Millie. What's the radius for this question? B? Very good. Keep it at 7 on 2. You can change it to 3.5, but I want you to practice typing on your calculator's fractions as well. Okay, keep it at 7 on 2. So here, let's write it out. You got 22 on 7. That's your pi. Times radius, which you told me is 7 on 2 squared, times, and notice this is a full circle, that's why it's 360 over 360. But what's 360 over 360, Bianca? How do you simplify 360 over 360? What's that equal to? A whole, which is 1. Very good, and that's why in your textbooks you'll find that they don't normally tell you to write this. But I'm telling you so that you know how to do 4F later, yeah? So now put all that in your calculator. Let's go. Calculator says I want 22 divided by 7 times. Again, if you can't do a fraction, you can do this. Bracket 22 divided by 7 times 7 divided by 2 Squared, if you don't have a square symbol on your calculator, you can actually do it by doing it again. 7 divided by 2, so that means squared. So 7 over 2 times 7 on 2 is the same thing as squaring. Multiplying by 1, your answer should be 38.5. So you could have done it the way I would have done it on my senior calculator. I would have done 22 on 7 times 7 on 2 all squared, and then times 1, and I still get the same answer. Okay, so 38.5. So here we go. 38.5. What am I missing? Good. Okay, so most students will say centimeters squared. It's squared centimeters, and you do need the units here. So this tells people that you're working with an area. So I do want to see that. So in the assessments, when I do the assessments, if I don't see the units, I will cross it off. I don't care if all this is correct. If it's 2 marker, you'll get 1 mark for the method, and then you get 0 marks for the answer. The answer mark must include units. Okay, and later on, when you get to year 9 and 10, that becomes more important. Okay? All right. So far, so easy, so good. Okay, full circle's pretty straightforward. Now we're going to move to some problems where you might not have a full circle. And that's where that second part that I was showing you, the portion of a circle will then come into play. So flip over. In your notes, flip over to the next question. You've got 2 types here, and that ends today's video. So you got this one, which is half of a circle. It's a portion of a circle. And then this one you have to problem solve. So here we go. Let's do this one first. They want you to find the area of these partial circles. I want to find the area of this circle here. Now, clearly that's not a full circle, because if I had a full circle, it would have looked something like this. Okay? But it doesn't look like that. I only want that portion of the area. So to get that area, first thing I need to figure out is, well, what's the angle for that portion? What's the angle? 180, because a full circle is 360, so half of 360 must be 180 degrees. So it's 180 degrees for this top half and 180 for the bottom, but I only need 180 for the top. Okay, so the area that I'm looking for is only 180. Area formula is pi times radius squared times the angle out of 360. Now I know pi, I'm going to use the pi symbol, not approximated, because I didn't ask for approximate. The angle that I want is 180 out of 360, but what is my radius? What's my radius here? Let's go with Ben D. What's my radius? Very good. Why not 12? Very good. So if you try to picture this as a full circle, notice 12 is actually the diameter and not the radius. Okay, so radius has to be from the center of a circle to the side. So it must be 6 kilometers as your radius. So be careful there. R is equal to 6. So put it together. This is what you type in your calculator. Pi times 6 squared times 180 on 360, which we already know is half. So type in your calculator, pi times 6 squared times half. Let's see what we get. Okay, so here we go. Pi times 6 squared. Remember, I can type pi on my one because it's a senior calculator. And times by half. You should get 56.5487. So 56.5487. That's not my correct answer. What's the correct answer? Can I please have? Let's go with... Who have I picked? Picked over there. Eamon. What's my correct answer? That's not the correct answer. Oh, yeah. They didn't say any rounding, so you can choose to round it up or you can just leave it as it is. It's up to you. Normally, the question should tell you. In this one, I didn't write it down, so you can leave it wherever. The general rule is that if you're unsure, you can leave it as 2 decimal places. Okay, so here would be 0.54, and like Eamon said before, don't forget the units, squared kilometers. Okay? Oh, sorry, that should be, if it's rounded to 2 decimal places, it should be 55. If. Commonly correct to 2 dec. Okay, so if they don't tell you, normally we do it to 2 decimal places, but you wouldn't be wrong. Okay. All right, last one. Let's do a problem-solving one. Have a look at your last question. Here's your last question. They want you to find the area of the shaded region correct to 2 decimal places now. My shaded region's here. That's the only portion I want. Can anyone see a way to get just that portion? Obviously, there looks like there's a square there. So the square has to do something. What am I going to do, Violet? Yeah. What you can see here is there is a quarter of a circle sitting in between inside a square. So if you actually got the area of a square, the full area, and then you remove part of the circle, well then that's what's left over is the area you want. So your aim is to find the area of a square and then remove this portion of a circle. Write it down. Here we go. We want the area of a square minus the partial circle. Now let's zoom in. How do you find the area of the square again? So let's say I want the total area of this square, which is in blue. How do you find the area of a square again? Can I please have, let's go with Harper. Yeah? Width times length? Correct. So it would be, what's the length at the moment? Very good. So we know that the length and the width are actually the same. So when you multiply them, it's just 7.2 times 7.2 to give you the area of a square. Once you've got the full area, that's the full area. What I don't want is, I don't want the full area. I need to remove this portion, which is part of a circle there. So minus, now the formula for a partial circle, we know again, it's pi times radius squared times theta out of 360. Looking at this shape here, so I'm going to try to focus on this partial circle so you can see. See, if I drew the actual circle, can you see? That's the full circle. That would have been the full circle that you wanted. But the portion that you're actually trying to get rid of is here. What's the angle for that portion? Just for that little bit of a circle, what's the angle? What's the angle there? Abby? 90. It says there. It's got a little square on the bottom there. That's 90 degrees here. So we know the portion of circle I want is 90 degrees, not 360. So in this question here, I know it must be pi times, this is 90 out of 360, which actually works out to be a quarter. But what's my radius though? What's the radius? Anyone see the radius? The nuke. 7.2, because it's literally here. That's the center of a circle. From here to the side of the circle, that is the radius. That's also the radius. So I know the radius must be 7.2. I put it into the formula, 7.2 squared. And this one was 7.2 times 7.2. This is what you type in the calculator. So in your calculator, this would just be 7.2 times 7.2. Total of the square minus the portion of the circle. Whatever's left over must be the area that I want. So here we go. Let's type in our calculator. I use brackets to separate it. So 7.2, that's a square, minus pi times 7.2 squared times 90 on 360. So I would type it all in one go, especially in the senior levels. We don't want to do bits and pieces and then round each one. Don't round them as you're calculating. You've got to do it fully, then round at the end. So here I press Control Enter and I get my answer as 11.125. Here we go, 11.125. Am I done? What am I missing? What am I missing? That's not how you pronounce it. Squared centimeters, but also what else? Rounded. What's the correct answer then? It's rounded to 2 decimal places. The answer should be, Thanuk. Very good. 2 decimal places. So you want, this is 1 decimal place. That's 2 decimal places. But you got to check the next digit. That's 5 or more. So that means the 2 has to go up by 1. So your answer is 11.13. squared centimeters. Any of those that is wrong, in your final answer, you lose a mark. That's how it works. Okay, so you want to be stringent in your layout. This is question method answer, vertical layout. That's what I want to see in your working out when you're doing your own exercises. I want to see the shape. For chapter 4 measurements, draw the shape and then do what I've been showing you, question method answer. What I've been seeing in some of your homework is that you just do question 1A and you write the answer for me. Okay, I don't want to see that. You could have just gone to the back of the book and just wrote that down. But even when you're revising, you have no idea what you were doing. See, if I didn't draw the shape and you just looked at this, even without the square minus partial circle, you wouldn't know what you're actually solving for. It's helping you to revise. So the better your notes now, the better for your revision later. And that's more important when you get to senior levels. You don't have time to revise. So those guys that are doing the exams right now, if they weren't clear with their working out throughout the year, there's no way they're going to cram one full year's stuff just in about a week or two for the exams. It's about preparation. So habits create preparation. Okay, so that's why I keep pushing question method answer. I know it takes longer, I know it's tedious, but it will pay off in the long term because it's better for you. It's better for your sort of habits. Okay, I'm going to stop the video here.